Seawater at 60 degrees Fahrenheit flows through an 18-inch wrought iron pipe at a rate of 3,500 gallons per minute. Determine F and HF for 500 feet of pipe. So once again, we take a look at this. Let us look up the properties of seawater, because we're going to need that for our equations. And we can find the kinematic viscosity of seawater is 1.26 times 10 to the negative 5 foot squared per second. And so the first thing I want to do with any of these problems is going to be calculate out Reynolds number. So to calculate out Reynolds number, what do I need? Well, Reynolds number based on diameter is VD over nu. I have diameter. I've looked up kinematic viscosity. What I do need, though, is I need the velocity. Velocity, we know, is Q divided by A. Our Q is given to us in gallons per minute, 3,500 gallons per minute. We know that we're going to want this in feet per second. So let's make those conversions. I've got 1 minute is 60 seconds. I want to take that gallons, change it into cubic feet. So I know 0.1337 cubic feet per gallon. If you ever forget any of these, just look them up in your book. Divided by the area, pi over 4. Our diameter is 18 inches. 18, I'm just going to divide that by 12 right off the bat, and that's going to give me feet squared. Gallons cancel, minutes cancel. I'm left with cubic feet per second. Divided by square feet, that's going to give me feet per second. I bash that into my calculator, 4.4137 feet per second. So now I can sit there, plug that into my Reynolds number equation, and calculate things out. 4.4137 feet per second times the diameter of, whoops, let's change the thing back. And we have 18 divided by 12, and that's going to give it to us in feet. Going to divide by 1.26 times 10 to the negative 5 foot squared per second. Foot squared per second on the top, foot squared per second on the bottom. Great, all unitless. 5.25 times 10 to the 5th. And tells us it's turbulent flow. Turbulent flow means that we are going to go to the Moody chart. So let's go to our Moody chart here. I'm just going to rewrite that so we can remember our Reynolds number is 5.25 times 10 to the 5th. I'm going to look up epsilon, so wrought iron will use 0.0015 feet. So epsilon over D, unitless parameter. So we've got feet on the top. That means our diameter has to be in feet. So 18 divided by 12 feet. And that will give us an epsilon over D of 0.0001. Okay, let's go to our Moody chart. Let us find 5.25 times 10 to the 5th. So we're looking at this line right here, just about. Now, epsilon over D, I've got 0.0001, 3 zeros and a 1, so we've actually got that line there. So those intersect right there. And so if I bring this over, those are going to intersect just about an F value of 0.15. So once again, anything from 1.4 to 1.6, I'm expecting it to be kind of in that area. So now that we have our F, which was Darcy friction factor, let's go to the Darcy-Colebrook equation. So H of F is going to be F L over D V squared over 2G, 0.15. We had 500 feet of pipe divided by a diameter of 18 divided by 12 feet. Our velocity, which we had calculated, was 4.41 feet per second squared. Divide that by twice acceleration due to gravity, so 2 times 32.2 feet per second squared. Units, feet cancel, second squared cancel. I'm left with 1 foot, which is what I expect. So I calculate out H of F. So in this case, I'm losing about 1.5 feet of head due to friction in this piping system.